So just note, the global frontier shift is different. Just a quick summary before I come to the real thing. Okay, it's different from the global Malmquist, the classical Malmquist, the biennial Malmquist, the meta frontier Malmquist. And we've looked at all the merits of the other 6 advantages of the global frontier shift relative to the classical Malmquist. Remember, this is a measure of productivity. So in formalizing it, we've indicated the producers in several time periods T using M inputs to produce S output. So on the basis of that, we can create input matrices and output vectors. Now we are on how you estimate the global frontier shift. You will estimate efficiency of all the firms, assuming there are 500 observations. 500 observation is made up, and they are in 10 time periods. Maybe 40 are in year 1, 45 are in year 2, and then different are in other years. When you combine all of these observations, they are 500. But you want to look at the relationship between year 1 and year 5. What you do is that you estimate the efficiency of all the firms in all the time periods relative to year 1, then the efficiency of all the firms in all of the time periods relative to year 5. That's it. So all the 500 firms will have a score relative to year 1. All the 500 firms will have a score, or 500 observations will have a score relative to year 5. Then you will calculate the geometric mean of those distances. So you see all that long column of scores. Then you take the geomean of that for the year 1. Then you see all the long column of 500 firms scores in year 5. You take the geomean of that as well. Then the global frontier shift becomes the geomean of the first year 1 divided by the geomean of the geomean of the year 1 scores divided by the geomean of the year 5 scores. That will give you the ratio, will give you the global frontier shift. Later on, we'll look at how you interpret the scores. So let's take the mathematical formulation. Okay. Yes, Prince. Yeah, Prince, you can go ahead. Is it that I can't hear him, or you can hear? Can you guys hear him?
No, Doc.
No, we can't.
All right. Okay.
Hello. Hello.
Yeah, go ahead.
Doc, I'm asking that in my case, I'm asking if I can use this methodology because it suits my industry. Like the sample sizes are different for every year and all those. I don't know if that is what I'll be doing, global frontier shift.
Well, the global frontier shift is only useful, like we indicated, when you want to make conclusion about the entire industry without regard to even individual firms. So you're not going to use individual firms as an example at all. You're going to get a score that reflects the industry, and then you talk around that score. But it's also important when you're dealing with groups. So if you are not really having lots of groups, a lot of diversity, okay, in your data set, it's not that useful to want to make a use of it. Then in that case, the classical Malmquist, the biennial Malmquist, or the global Malmquist is what you need. Okay. And there's no bootstrapping for this very one. So yeah, I don't think, no, that's not what you need for your work. But you have to understand how this relates to your work, so that at a later time, when you have a lot of groups in your work, when I say a lot of groups, like at least 3 or 4, at least 3 groups, that is when your global frontier shift is very, very important. When you have multiple time periods, like, okay, you have multiple time periods. But please note that multiple time periods, a lot of unbalancedness is fine, but your conclusion is going to be overall conclusion. That's what you should understand. So what I mean is that you can't go and talk about BDCs. Okay, you want to make conclusions. So you say that the BDCs in 2020 are better than the BDCs in 2021. Okay, the best performing BDCs in 2000 outperform the best performing BDCs in 2021. Now, you are just making that. You can't prove that with an example. You know, like in the normal Malmquist, where you can say that, okay, for example, when you go and look at this particular BDC, okay, and you look at this company, you will notice that, no, you can't use individualized examples to make up your point. You are making generalizable populative statements. So, yeah, we can check it later. Yeah.
Okay, thank you.
All right. Now, so how do you calculate the global Malmquist? Now remember, the global frontier shift is the second term in the global Malmquist. The global Malmquist is given by the global efficiency change and the global frontier shift, which is a global technological change. Okay. Now, the global efficiency change, the way you calculate it is very important. That is why I indicated that this thing is for both time and group. The global efficiency change, watch something here. You can see that the J means that you are estimating the efficiency of a particular firm. The J means particular firm relative to a particular time period, say T plus I. Now you can see that we've made T plus I. Why not T plus 1? Because we are not just dealing with comparing the thing relative to an adjacent year. You can compare the efficiency of a firm relative to a particular year, and then efficiency of a firm relative to a different year, not just 2000, 2001, 2001, 2002, 2002, 2003, adjacent, no. You can compare 2000, 2020, 2000, 2018, 2022. So you can compare different years so that I can refer to 2 or 3 or different years. So the global efficiency change, okay, I'm just taking an output orientation here. The global efficiency change is efficiency of a firm in year 2 relative to frontier 2. Okay, that is a global efficiency change. Okay. Then divided by the efficiency of a firm in year 1 relative to frontier 1. Okay, that is it. Now watch it carefully. You will notice that I've raised that to 1 over J. The capital J is referred to as all the firms. So it's simply the geometric mean. So is this the way you calculate this is simple. It's the normal calculation. You calculate everybody's efficiency score, everybody's efficiency score, everybody's efficiency score. Then you take the geomean of all of that. That's it. Okay. So this symbol here, this pi symbol here, is the technology index where you are taking the geomean of all the efficiency scores. Efficiency, not technology, efficiency. And then you get 1 score. And that 1 score will be for a particular year for that industry. That is not a focus. The focus we are going to do is the global frontier shift here, the right-hand side. What is that? How do you calculate that? Well, watch it. It's a technology index of year T plus I divided by the technology index of year T. What does that mean? What it means is that, in fact, at this stage now, watch the terms in the bracket compared to that of the global efficiency change in the bracket. In the bracket here, you will notice that it is to the power tau. It's not to the power t or t plus I. It is to the power tau. What is tau? Tau is all the time periods. So there is no particular time period that you are. So what you are doing is that you are taking the efficiency of all the firms in all time periods. All firms, that's the tau. When it comes here, tau has been defined as 1 to capital T. All the firms in all the time periods relative to that small time T. And then all the firms relative to all time periods, all the firms in all time periods relative to the frontier T plus I. The subscript C here means we are dealing with constant retention scale. Okay. All the subscript C means that we are dealing with constant retention scale. Okay. Now, what that means is that we will not experience infeasibility. Okay. But if we are dealing with variable retention scale, we will experience potential infeasibility. Okay. Now, so you take the technology index, which is efficiency of all the firms in all time periods relative to frontier T and then frontier T plus I. And then you take the geomean of all of that. Okay. So the geomean of that, and that is 1 over J times T. Now, why is it that when I was taking the geomean of this second one, I have 1 over J times T, but when I was taking the geomean of the efficiency, the global efficiency change, I had 1 over J. Who can tell me that? So if you look at the global efficiency change, the geomean is 1 over J. You ignore the time. But when you come here to the global frontier shape, the geomean is 1 over J times T. You incorporate the time. Why? Who has an idea? In fact, of course, your capacity to have an idea about this is indicative of the fact that you understand in total what we are studying. So who has an idea? Otherwise, I'll call somebody. So you better raise your hand so that it looks like it comes from you than you are forced to indicate that I took it from you. What is causing this, the difference in this 1 over J and then this 1 over J times T? Yes, Miriam.
Yeah, the time period.
Hey, are you teaching or you are answering a question? You're
I'm
supposed to
answering
teach
the
us.
question.
So no. You're a postgraduate student, you're supposed to teach us. So explain. You don't just say time period.
So it's 1 over the sample size times the time period.
And we all know that that is it. I didn't tell me what did they mean. No? I didn't tell you that, tell me the meaning. If I write J and I write T, these have been defined above already. I said why, I didn't say what is 1 over J times T. And what is 1 over J? I said, why do we have 1 over J? Why do we have 1 over the sample size? And then the other one, we have 1 over the sample size times T. That's what I'm asking. Michael. And in fact, there's an example down here. Yes, Michael, why?
So I think the global efficiency change is concerned with the improvements of a DMU between 2 time periods. That's why we don't have, we don't consider the time period when calculating, when finding the geomean, because it's just concentrated on the DMU. But then the global frontier shift is concerned with all DMUs in all time periods. So if we are to find their geometric mean, then we need to consider the dimension of all the DMUs and all the time periods, more like a matrix. We use the J of a matrix.
Very good, very good, very good, very good, very good. You got it. You got it. So once you are just looking at 2 time periods for the global efficiency change, 2 time periods, you've taken the 2 time periods into consideration already. So time periods is captured already. And those 2 time periods have been captured already. If you look at the things in the outside the bracket, the frontiers have been captured. The firms that are being estimated have been captured already. You don't need any more time dimension. But then with this one, there are even time periods that you don't see, because capital T means that there are several time periods. There are several times. And so because of that, it has to be, distinguished in that regard. So this is a typical example. So based on the one at the bottom here, let me ask you, how many observations are there? How many observations are there? If you look at the, sorry?
141.
And how many time periods?
7.
And what is the ending time period?
Um, 2004.
Yeah. Yeah, that's it. So that's it. Okay. So note that the global frontier shaped, it gives you a single score. Finish. Because it's measuring movement of frontiers, whether a particular frontier is performing better over time or not. And this could potentially mean or indicate improvement in the technology. Yes, Michael.
Yes, I have a question on the number of time periods. Are they not rather 6 in the example we just looked at than 7?
Okay, explain.
Oh, okay. I wasn't counting 98. That's
Okay.
That's what I got it now.
All right, okay. So that's it. Now, let me give you a picturesque understanding of this. If you look at this data set carefully, and please look at it carefully, how many frontiers do we have? Tantam. How many frontiers do we have? How many frontiers? Kizito, are you here? Yeah, go ahead.
Yes, Doc. I'm here.
I am noting those of you are participating. Those of you are participating. Yes, how many frontiers are here? Yeah, just answer.
2 frontiers, Doc.
How many groups are here? How many groups are here? Anybody?
Well, there are 3 groups.
Okay, good. Mention them.
So there's one group which is represented by a star.
What
A blue star.
Good.
And then there's another group represented by a green dotted circle. And another group represented by a red square.
A red square. Okay, all right. So these are 3 groups. You can see that the 3 groups are appearing differently. What I mean is that some of the groups are intersecting some of the groups. Okay. Now, this very graph is not intersecting. Okay. Even though it's also not exactly parallel. Okay. It's not intersecting, and it's not exactly parallel as well. So there are 3 groups. The question is, how do you classify these 3 groups? You can classify these 3 groups and even ignore time. And then classify. How do you classify? If we to use classification algorithm in machine learning, okay, we would have found a way to separate the stars from the round dots. Well, here you are going to see how everybody sees the blue frontier. The blue frontier was formed by the blue stars, and the green frontier. So even though we have 3 groups, we are comparing 2 groups at a time. That's the whole point. We are comparing 2 groups at a time. So let's try to see how you interpret the score. This is the most difficult part in the estimation of the global technological change or the global frontier shift. Remember, it can be about time differences between time, and it can also be about differences between groups. So I'm going to give you how to interpret both of them. So let's start with the time first. If you have the global frontier index between frontier 1 and frontier 2, and the value is greater than 1, for the value, listen carefully here, for the value to be greater than 1, the ratio of the geometric mean of frontier 1 and the geometric mean of frontier 2, which one will be bigger? Which one will be bigger? Let me explain to you what I mean. Okay. So you have the geomean. Okay, watch here. You have the geomean of frontier 1 divided by the geomean of frontier 2. And when I say frontier 1 and frontier 2, I'm talking about the technology indices. Okay. Like I'm talking about the efficiency of all firms relative to that particular group 1 of time period 1. And then what you do is that you take the geomean of that. So that's what I have there. So this is a global frontier shift here. So I calculate this global frontier shift, and I have a value of greater than 1. If I have a value greater than 1, which of the 2 ratios, the numerator or the denominator, which one is bigger? Which one is bigger? Who can tell me? Between the numerator and the denominator, which one is bigger?
Numerator.
Numerator, very good. So it means that the value here is the bigger one. Listen carefully. And the value down here is a smaller one. Okay. Now, it doesn't matter whether you are doing input orientation or output orientation. If a value is closer to 1, okay, or a value is moving away from 1, which one is better? If a value is closer to 1 and a value is moving away from 1, whether it's input orientation or it's output orientation, the answer you're about to give me is the same. Which one will be better? Is it the one closer to 1, or is the one, away from 1? Mimi.
Doug, please, the one closer to 1.
Why?
Because it's close to efficiency.
Okay.
1.
Exactly. So the value is the one closer to 1. So even if you are using input orientation and you have 0.5 and you have 0.8, input orientation, 0.8 is better. And the reason why 0.8 is better is because it's closer to 1. If you are using output orientation and you have 3.5 and then 2.9, which one is better? Anybody? Which one is better? 3.5 and then 2.9. Which one is better?
The 2.9 is better.
Why?
Because it's closer to 1.
That's it. So guys,
than 3.5.
That's it. So 2.9 is better because it's closer to 1. Now watch this. Francis, is your hand up? So,
Yes,
what?
yes, Doc, my hand is up. I want to ask a question.
Uh-huh.
Okay, so I was thinking, since it's a shift we are looking at, a frontier shift, which has to do with change, and it is one mean divided by the other. I think if it is moving away from one should mean there is a change. But if it is close to one or it is exactly one, then it means there was no change between the first and the second frontier. So I don't see why, if there is no change between the frontiers, it makes it better.
So give me an example what you mean by there's no change between the frontiers.
So if there is no change between the
Give
frontiers,
me an
then
example.
an example. Okay,
Yeah.
so if we calculate the geomean for frontier 1 and we get 2,
Mhm,
and we calculate the geomean for frontier 2 and we get 2,
mhm,
if you divide both, you are going to get a frontier shift of 1.
mhm.
So which means there was no change between the first frontier and the second frontier.
And when there is no change between the first frontier and the second frontier, what does that mean in terms of betterment? It means none is better than the other.
Yes. So if none is better than the other, then why does that portray efficiency? Because I am thinking, if you are moving, if it's bigger than 1, that is when we will say, okay, this one is better than, the bigger one is better than the smaller one.
But we can say that you can say that the smaller one is also worse than the bigger one. We can use worse and better.
Yes,
Mhm.
that's what I'm trying to say. So definitely there should be a difference. So it's either one is better or one is worse.
Yeah, but
And
when they are the same, when you have used the word, when is either one is better and one is, but when I'm saying that when two things are the same, it means none is better, none is worse than the other, right?
Yes. So how then does that become efficient? Because one must be better for one to be efficient than the other.
No, I'm not using that. The fact that none is better than the other makes something efficient. I'm not using that to define.
Miriam's explanation for the one closer to one says it makes that efficient.
No,
I said it's closer to efficiency.
Yes. So closer to 1 or 1 means efficiency.
No.
Yes.
The definition, I'm only saying that the definition of efficiency is when an efficiency score is 1. Do you agree with that?
Mm-hmm.
The definition of an efficiency, a firm being an efficient, is when an efficiency score is 1. It doesn't matter the orientation. Okay. So it means that, and do you know that the scores that we have taken their, whatever situation, these scores are efficiency scores.
Yes.
Okay. And because they are efficiency scores, they define the efficiency of each individual firms.
Yes.
When I say they define efficiency in each individual firm, because remember, we measure the efficiency of all the firms relative to one particular year's frontier. And we recorded each one of those efficiency scores for that year 1 or frontier 1. And then we measure the efficiency of all the firms relative to the second frontier. Okay. So we recorded each one of them. Okay. Everybody that we had before. Okay. So everybody that was in the previous one is also measured relative to frontier 2. These things that you are seeing here are efficiency scores. Okay. Now let's assume that we are dealing with input orientation. If it is input orientation, it means that if the firm has a score of 1, that firm is efficient. And if he has a score of less than 1, that firm is inefficient. You agree with that?
Yes, I agree.
But if you are efficient, let me ask you, if you are efficient, doesn't that mean that your efficiency is better than the other guy?
Yes.
Mhm.
Yes,
So if that is yes, and if I take the geo-mean of the first one and the geo-mean of the second one, is it still not showing betterment or improvement? If you don't want the word betterment, is it still not showing improvement in terms of time? I use betterment in terms of time and group, but that is a little bit difficult to comprehend. It is not showing improvement. Suppose, for example, I have an efficiency score of 1. Let me put it there, okay, of 1 this year, and I have an efficiency score of 1 next year. It means that I have not changed in my efficiency in terms of dynamic. I know you are thinking so much about timing, forgetting that the word better here means improvement. So if I say better to represent improvement, is that better for you?
Yes,
Does that now make sense?
Yes, it makes sense. But so if you were efficient in year 1, your score is 1. You are efficient in year 2, your score is still 1. There is no change in your efficiency from year 1 to year 2.
Good. And you are using the word change because you are thinking in terms of time, right? And I agree. But what if it was a group at this stage? What if this thing is not about year 1 and year 2, but what if this is about a foreign company and then a domestic company?
Yes, so the same analogy will hold. If the domestic company is efficient and the foreign company is also efficient, then there is no difference between the
You see the word you use. You see the word you just used. You didn't say there is no change. You just used there is no difference. But it's the same thing. So that word there is no difference, okay? There is no difference. That word there is no difference. If there was a difference, wouldn't you say that that particular foreign company is better than the other company? Wouldn't you have said that?
Yes, if there was. That is if the local company had a score lower than.
Yes, if the local company had a score of 0.7 and then the foreign had a score of 0.1, you would have said that the foreign company is better than the local company, wouldn't you?
Yes, definitely.
That's what I'm saying. I'm saying that it's because you are thinking more in terms of timing. Okay. But I'm using a general term better to refer to an improvement.
Yes, so Doc, in that same scenario, using the group, so if the local firm had a score of 0.7 and the foreign firm had a score of 0.1, and now we are going to find the shift, the difference, frontier difference in this case. We are going to divide 1 over the other.
Why would you divide 1? You can also divide 0.6. What number did you use?
So 0.7 over 1. Yes,
you can also do that, right?
So definitely you must move away from 1. Then we will see that there is a difference. But if you move,
so do the division. Do the division and tell me how you would have now used your better or your worse or your difference.
Okay, so when we do it this way, it's 0.7 divided by 1. Then we are moving lower. It will be lower than 1.
Yes.
The
and so now that it is lower than 1, what would you say it is to what advantage? Which of these two groups?
It is to the bigger one's advantage.
Which bigger one?
The one with the bigger efficiency score.
Okay.
That is the one with the 1.
And why?
Why? Because the the difference is not 1, it's less than 1. So we are going to look at the one we used as the numerator and the one we use as the denominator. So if the final
So how
score
will you
come out,
interpret the 0.7?
the 0.7 is inefficient.
Yeah, but how will you interpret the 0.7
Okay, in terms of the difference.
in terms of the groupings? In terms of these local and foreign example?
Yes, so we are going to, if we use that in the numerator, then we are going to say that the one in the numerator, because the total difference is lower than 1, we are going to say the one in the numerator is inefficient as compared to the one in the denominator.
How will you use the number 7 to make a calculative sense? You are only talking without using the number 7.7, sorry. Who called?
Doc, I'm the one.
Mhm.
I was thinking if that is the case, then we can
If
say
what is
that
the case?
based
You are
on
cutting in the thing. If what is
discussion,
the case?
if the group 2 or if the one with the efficiency score of 1 did or performed better than that of the 0.7, then it means that the group 2 outperforms the group 1. That's my understanding.
I've forgotten which one we're even dealing with.
So we
was
said
given
the
the group
local,
scenarios, yes,
yes.
2 groups, 1 local and then 1 foreign.
So use the word local because now you brought the word 1 and 2 and it confused me.
Francis, please, the group 1 was the local firm, right?
Yes, the local firm had 0.7 and the foreign firm had
0.7.
1.
Okay.
Yes.
So it will mean that the foreign firm outperforms the local firm.
By how much?
Yes. By.
Be careful with your next sentence.
Okay,
Then
so
No,
I'll
you
not.
see, it's not just
that will be,
talking what you know. It's about using the numbers. I kept telling you use the numbers.
so
By
0.7
30%.
divided by 1 will give you 0.7. So the
Yes.
foreign firm outperformed the local firm by 70%.
Do you think that makes sense to you? Come on, think about it. Think. You just think. Does the foreign firm outperform the local firm by 70%?
No, it should be 30%.
Well, you just said it. You see, so I'm saying that, therefore, when you bring, so it's by 30%, isn't it?
Yes.
That is why. And so if the foreign firm outperforms the local firm by 30%, then it means that the local firm underperformed the foreign firm by what?
70%.
70%.
It makes sense. Now, by the way, what you've just done here is that you have used efficiency scores, but you have not used technological. Let me just explain. What you just mentioned here is indicative of the fact that all the 2 firms were measured relative to the same frontier. I want to repeat that. When all the 2 firms are measured relative to the same frontier, then what you have just indicated hold. Now, let me give you an example, another example. Suppose that the foreign firm was super efficient. Okay. Are you there?
Yes, sir.
I'm talking
Yes,
to Ryan. Suppose
Yeah,
the
Doc, I'm
foreign
here.
firm was super efficient. Give it a particular value for me unless you do something.
If it was super efficient, then it should be, let's say, 1.5.
Okay, so let's do 1.5.
Orientation.
So do 0.7 divided by 1.5. Well, let me do one. I wanted a value where I'll get a simpler number.
You have 0.47.
You had what?
0.47.
.47. Yeah, so what would you say? What would you say now between the two?
So now you can say the foreign firm outperformed the local firm by 53%.
Okay. Now, so I'm asking you now watch something. What if there are more of these foreign firms and there are more of these local firms, and then you estimate that of the foreign firms? And again, because there are more, some of them will be efficient, some of them will be super efficient, some of them will be inefficient, and so forth. I don't know what it is. Okay. And now I have a collective value. Watch what I'm saying. I have a collective value. And that collective value, okay, what do you call it? I have a collective number. So let's say there are 20,000 of the foreign firms, and there are 15,000 of the domestic firms. And then I have several of these scores. Some are efficient, some are inefficient, some are super efficient, and all of that. And then I take the geometric mean, because I need one score for all of the foreign. Okay? And I'm going to use the same thing that I use. I take the geometric mean of the local, and I got 0.7. Now, some were efficient. Okay, let me put it there. Some were efficient, some were inefficient, some were super efficient. And I take the geo mean of them, and then I got 0.7. And then, what do you call it? I take the geo mean of the foreign, and I got 1. All of them together. What would you say? What would you say about the score?
So the foreign firm outperformed the local firms by 30%.
Now, how could that have been an outperformance when the change is from the frontier? Now, remember, it will be from the frontier than from the efficiency scores. Because that example I gave you is an indication that, okay, all the firms had a score of 1. Do you agree with that? The geo mean will also be 1.
Yeah.
And they all had a score of 1.
Yes.
So it means that and if it was time between the two periods, the shift is constant.
Yes, it means the shift is constant.
And when shift is constant, it means that you've not shifted.
Yes.
And if you haven't shifted, what does that mean to your movement?
It means your movement is constant.
Okay, good. Now, I want us to go and change the value, because this is let's take an output orientation. Okay, that'll help you. And let's say that you have a score of, I'm just writing it on the screen. You have a score of 3, okay, for an output orientation, and another has a score of 1. Okay, do your calculation and let me see. Do how you'd have done. Okay, you call a 3 local and you call a 4 foreign, right? That's how you call it. How would you do your ratio?
So the ratio can be either local over foreign or foreign over local.
Okay, so choose one and tell me the value.
So if we choose the local over the foreign, we would have 3.
Okay. So how will you interpret that term?
So for an output orientation, the 3 will mean the foreign companies outperform the local companies by 300%.
Are you sure? Are you very sure what you're saying? 300%.
200%.
Okay. So I've even forgotten where we came from here. But the point is this. I don't know what point I made that brought about it. Okay. The point is that if I put the point that I want you to understand the global frontier shift as a shift, not just as an efficiency score. And it is a shift taking into consideration several people or several DMUs. Okay. And the score is an average of how they all see how the frontier has shifted. So on average, if you have a score that is greater than 1, okay, between period 1, and you understand time, between period 1 and period 2, and you have a score of positive, a score greater than 1. What it means, that I give an example of say 1.8, okay? What it means that if all the DMUs are projected onto the second frontier, because remember they were on the first frontier before they went to the second frontier. If they were all projected onto the second frontier, they would only have an average score of greater than 1 if they were measured relative to the first frontier instead. Okay. In other words, if you put all of them onto the second frontier, which is a subsequent time period, okay, and now you are measuring all of them relative to the first frontier, okay, they would have an average efficiency score greater than 1. So if you calculate the ratio and the ratio is greater than 1, it shows an improvement in the frontier of the DMUs that you are looking at. Okay. Like I said, I've forgotten exactly what led to our deep discussion, but it shows.
No, please, I can remind you where we were before we deviated. So we started the interpretation, and then I think Miriam mentioned that, or you mentioned that the value closer to 1 is better than when you are moving away from 1. That was when Francis came to ask his question.
Okay.
Initially, you asked that between the frontier 1 and frontier 2 with a value greater than 1, what would be the ratio of the geo-mean of the frontier 1 to that of frontier 2, in the sense that whether the ratio will be greater than or less than?
That's what he said. That if you have the score global frontier shift, which is 1.6. And that 1.6 is presumably 3.2 over 2. You did indicate that, and that's why I say you all have been saying the same thing, but just as the use of the word. You did indicate that the thing that you said that it means that one is, I don't know which word you want to use, whether it's improved. Can we use improved and better at the same time now from your perspective?
Yes, so we can use improve.
Okay, so one has improved by 60% more than the other, right?
Yes.
Good. And the one that has improved by 60% more than the other is the is the denominator, isn't it?
Yes.
So the
Yes.
denominator has improved than the numerator. I can say that if there were groups, I could say that the denominator has improved, I'm using the word improved, than the numerator guy by 60%. Can I say that?
Doc. Yes, Doc.
Okay. So what she is saying is that this value, where you have two values here, and you have, what do you call it? You have two values here, and you have 2, and you have 3.2. In terms of efficiency, for interpretative purposes, to make sense, in terms of efficiency, which one is closer to efficiency?
The 2 is closer to efficiency.
So what she's saying is that the one that is closer to efficiency is the one that the change is to advantage of.
Yes.
That is it. It's not something specific. It's not something so strange, but the way to interpret it to make sense, the one that is closer to an efficiency score of 1 is the one that will be the better one. And so I would have said that if you like, come out with anything, and I will use that anything to calculate, and I will look at the improvement situation, and you will see that that assumption holds in all respects. If this doesn't make sense. So just as you agree that the denominator is the one that has improved, have improved by 60% more than the numerator. Okay. That is the same way that she says the denominator is, for her to remember, the denominator is the one that is closer to an efficiency score of 1, because whatever it is, these numbers all came from between, there was a benchmark value, and the benchmark value is 1, which eventually led to this, that the 3.2 and the 2. I'm not talking about the 1.6, because the 1.6 come from the 3.2 and the 2. And those 3.2 and the 2, there is a linear programming algorithm that eventually fixes them. And when you are closer to 1, you are efficient. Or even let's not talk about it being efficient or being efficient. When you are closer to 1, you are seen as try and be closer to 1 than try and be not closer to 1. So if you pick any other number in this world, the one closer to 1 is the one that you will speak of in favor of improvement or decline, or in favor of the change.
Yeah.
Do you get the argument? That's why I'm saying you're all saying the same thing. And for you to better understand, maybe you want to pick another value and you double check and see.
Okay, so let's stick to the 3.2. This time, let's say the denominator was very efficient. So we have 1.
Okay.
So we are going to get a shift of 3.2.
Okay.
Okay. So now the shift of 3.2 is farther away from 1 than the shift of 1.6.
The shift
So
of
in that case, so if we do 3.2 over 1, when the denominator is very efficient.
Yeah, but remember, I'm
that
not comparing two different GFS. I'm comparing a numerator and a denominator.
Okay, so my confusion came about when you asked the GFS figure being closer to 1. So
Oh, really?
yes.
It was the numerator and the denominator being closer to 1. That was what I was talking about.
Okay, if it's about the frontier itself, then
yes,
it's understandable. But if it's about the shift, then that was when I was wondering.
Okay. So it's about the numerator or the denominator being closer to 1. And the denominator, the numerator and the denominator being closer to 1, the one that is closer to 1, it is the one that everything is spoken in favor of. So whichever global frontier shift, when you do the division, the ratio, whatever score you are speaking of, if the score is a positive score, it's a positive score in favor of the lower value. Well, that is if it is positive, right? In favor of the lower value, this case. Now let's say that the score is less than, not positive. If it is greater than 1, that's what I meant. Okay. If it's greater than 1.
Okay.
Not if it is positive. Because if it's greater than 1, you are going to just say this one, for example, the 1.6 here, you are just saying that it means that there has been 60% improvement. That's what you said.
Yes.
The reason why you said that there has been 60% improvement is that you adjusted it relative to 1.
Yes.
You interpret it as a productivity measure, which is true. It's supposed to, because it's a global. The thing was from the perspective of everybody looking at that frontier, and everybody looking at that frontier gave their score, and everybody looking at that other frontier gave their score, and we had this ratio of 1.6 from this 3.2 and then 2. So from this 3.2 and the 2, you said that the speech is going to be in favor of the denominator value, not value, the denominator. So if it is going to be in favor of denominator, then you are going to say that there is a 60% improvement, and that 60% improvement is in favor of the denominator.
Yes.
And if it is in favor of the denominator, what if the value is 1? Then you will say that there is a 10% improvement in favor of what? The denominator. Isn't it?
Yeah.
What if there is 0.8? For us to be 0.8, then the lower value will be the numerator, isn't it?
Yes.
So it means that 0.8 will mean that there is a decline, 20% decline in favor of the numerator.
No, the decline will be to the denominator, since that one is bigger than the numerator. So the improvement will be for the numerator. So we can interpret it.
There will be a 20% decline.
Yes.
Okay, let me put it up. There will be an 80% improvement to the numerator. That's what I mean.
Yes, yes.
An 80% improvement to the numerator, and hence a 20% decline to the denominator.
Yeah.
Now watch that. What do you call it? That 80% improvement. So in this case, the point being made was that the one that is closer to 1, this ratio, the one that is closer to 1 is the one that has the improvement. That's the point I was making.
Okay, Doc.
So if we had used 0.8, okay, 0.8 was the score. And what would have led to 0.8? 2 times 0.8 is what?
1.6.
Good. So it would have been 1.6 divided by 2. Okay. For you to get that 2.8. Sorry, 0.8. So this 1.6 is closer to efficiency than the 2.
Yes.
And that is the one that carries the improvement factor. So of course, this value is not an improvement, okay, but you can see the improvement in it. If you're able to find the deterioration factor, which is 20%, then you know the improvement factor. I want to be sure you still get this one, because like I said, the interpretations are usually the difficult thing. Okay, so now let me summarize with this before we go into an example. So this point is indicated that on average, and again, it's because your mind, you are a bit biased because you don't normally think through in terms of groups. And because you don't normally think through in terms of groups, okay, I hope you do. I hope you do, okay? And
Yeah,
she too doesn't, you do, eh?
Yes, I am.
You are or you did?
I am now.
Aha, good, I like that one. You are now, okay? And she too, she is now, because the thing is that she's also biased. You know, she's not in favor of time. She's also in favor of groups. So sometimes you people will be saying the same thing. If on average, the group 1 best practices outperforms those of group 2, what it means is that DMUs obtain a composite score for group 1. That is the score I just talked about, the numerator-denominator thing. The DMU obtains a composite score on average lower. Do you see the word lower here?
Yes, Doc.
Lower than its counterpart of group 1, group 2. So 1.6 and then 2, okay, you will get a score of 0.8. Okay, and he's saying that if on average group 1 best practices outperform, in other words, group 1 is better than group 2, then group 1 is the one having this score. That's what he's saying. It obtains a lower score, a lower composite score. Composite here means the geometry. A lower composite score than its counterpart of group 2. Why? Because they are assessed relative to a less demanding practices, okay, in the group 2 case. So in other words, and it is on the basis of that you say this one has improved. This group 1 has improved. That's why you like the term improvement and decline. So in this case, your group 1 has improved because it has a lower score. So the one that has a lower score is the one that has improvement. The one that has a higher score is the one that has the deterioration or decline. Or in a group, the one who is looking at group's case, what I just said is for time. The one who is looking at group's case, the one that has a lower score has a better frontier, a favorable frontier than the one that has the higher score. Okay. And so when you now come and check the final score here, and the final score here is an improvement. Let's say it is 2.0. Okay. Then we can say that there has been 100% improvement. And that improvement will be the one with the lower score on the ratio section. But if the thing is, 0.8, as you can see here, then that 0.8 is a decline, of course. And because it's a 20% decline, then that decline is for the denominator value, a group, or denominator time period. Whereas the improvement of opposite of that or reciprocal of that will be for the numerator, which has the lower score. And that is a point. And it's the same thing that was said in the early census. It says that greater than 1 means frontier on average has improved during period that and that. To the extent that observations were projected onto year 2 frontier, they would have actually been on an average have a positive efficiency score. Average, if they were measured against the frontier 1 instead. But the simplest explanation is what I've given to you by the ratios. I want to take a bit of time for you to be sure that it is sinking in, because you'll be doing most of these interpretations before we move on. And for those of you who did not get it, you can now ask your questions. We'll look at examples, by the way, don't worry. Look at examples as we move further. But I want you to note that in time, when you're dealing with time periods, we talk about shifts. And because we talk about shift, the shift is either shifting forward or shifting backward. And therefore, we talk about improvement and deterioration or decline. But when you're dealing with groups, you don't talk about shifts. You don't talk about improvement. We don't talk about decline. We don't talk about moving forward and moving backward. No. We talk about being better, being performing, or more performing, or outperforming. That's the right one. Being better or being outperforming. Okay. But sometimes, because I understand both ways, I tend to put the two together. I can even say that this year 1 frontier, year 1 is time. Year 1 frontier is better than year 2 frontier. I use that word better because year 1 frontier, this year 2 frontier is better than year 1 frontier. I can say that, which means that the frontier has improved because you move from year 1 to year 2. But if the frontier between you are from year 1 going to year 2, you can move from the year 2019 to the year 2020, and your entire frontier could decline because of COVID. And because it's declined in that sense, we can say that let's say that 2019 frontier is frontier 1, and then year 1, and then 2020 frontier is frontier year 2. We can say that the frontier deteriorated, or the industry of firms, okay, decreased their frontier. Or let's say the frontier improved. Or the best word, that's it, the frontier improved. Or you can even say that the best performing firms it deteriorated. Or you can say the best performing firms in year 1, and declined their performance or reduced their performance in year 2 because of COVID. Okay, that timing aspect, you tend to understand it. That's okay, but you also have to understand it in terms of better. Okay? It means that you were better in 2019 than you were in 2020. That's also what it means. It means that you are worse in 2020 than you were in 2019. That is also what it means. Does it make sense? Does it make sense, all of you?
Yes, Doc.
Yes, Doc.
Okay. Now look at this. This is a global frontier shift of year 1 and 2. Okay. Shift of year 1 and 2. And look at the value. I shouldn't have even brought that. But going to this, Francis, are you watching?
Yes, Doc, I'm watching.
So if you look at it, this is from a paper, okay? So looking at this value, you have frontier 1 score, that is the geometric mean of all the firms relative to frontier 1. It had a score of 95%. The geometric mean of all the firms relative to frontier 2 was 115%. When you take the ratio, you have 1.21, okay, which is greater than 1. And in terms of timing, what does that mean? Okay. So the paper indicated that it means that on average, the frontier has moved 21% forward. And it's the 21% forward is the 21 after the 1. So it's moved 21% forward. Further explanation. It means that period 1 frontier, which has a lower average efficiency score of 0.95. That period 1 frontier, on average, performs better. That is, outperforms or perform better. That down shouldn't come. Performs better or outperforms than period 2 frontier, which had what? A higher average efficiency score of 115. Or on average, the best practice firms in year 1 outperform those of year 2. That's what the paper just said. Michael. Yeah, Michael, your hand is up.
0.95 over. Yes, Doc, can you hear me?
Yes.
Yes, I said my issue is with that 1.21 because 0.95 divided by 1.15 should give us 0.83.
Oh, is it?
Yeah.
Yeah, it's true. Hold on, let me see. So yes, it was a typo. So it's supposed to be 1.15 over 0.95. And what do you call it? So, and that gives you 1.21. So on the basis of this, if there were groups, Francis, going back to you, if there were groups, the group 2 is better than the group 2 frontier is better than the group 1 frontier. If there were time periods, what it means is that the period in year 2, okay, the frontier period in year 2 is better than the frontier period in year 1. Do you get it? And that means also that if we are talking about movement, then that means that the frontier have moved forward, okay, than moving backwards. And when I say a frontier has moved forward, let me just show you something. Suppose, and I'm just drawing even an input orientation. Okay. When you have this input orientation, and you have another one here, like that. Okay. And this is frontier 2, and this is frontier 1. Okay. Has this frontier from year 1 to year 2, has it moved forward or backward?
Doc, it has moved forward.
Perfect.
Since it's input oriented.
Good.
Since it's input orientation,
exactly,
it must be closer to the origin.
Very good. Now, if you have this, okay, this is output oriented, and you have that. As a frontier, and this is year 1 and year 2, as your frontier move forward or backward?
It has moved forward.
Exactly. So the word moving forward means that the second year, because we are in terms of year, we are always going 1, 2, 3, 4, 5. It means that the second year is better than the first year. So it means that the first year has moved forward. That's what it means. Okay. And that is what this principle is saying. And I'm just telling you that one way to come with this beautiful conclusion is that you always check the value. The denominator value is a smaller one. And because it's a smaller one, it might look like it's the one that has what? Inefficiency. And yet, that is the one that is the better one in terms of groups, or that is the one that has improved, or that is the one that the improvement is centered on, okay, or the change is positive on, and whereas the decline is positive on the other. If we had done 1.15 0.1, sorry, if we have done 0.95 over 1.15, what would have been the score?
0.83.
0.83. Okay. So what it will mean is that the frontier, if it was group, okay, you would have said that the group 1 is worse. The group 1 frontier is worse than the group, what is that? Group 2. Okay. That is what you'd have said. Is worse than the group 2 by approximately 17%. Okay, by approximately 17% in that regard. Or in your case, you would have said that group, did I say 0.98? Hold on. Let me just verify, because I didn't calculate, I just took 0.95 divided by 1.15. Yes, it's 82. Okay, 83. Okay, so we would have said that the if it was time, okay, if it was time, it means that the frontier 1, how do you put it? Okay. If you had done it like this, then because it's time, and you know, with time, you move from 1 to 2. Okay, you don't move from 2 to 1. Okay, so you have to now speak of it in terms of, and of course, if it is this very value, then you should know that this one is the year 1. And if this is the year 1, then you have to now turn it the other way for it to make sense. In fact, if it is time, you have to be careful about the way you arrange the thing. If it is about groups, there is no movement per se, because there's no movement, okay, the counting movement, you just look at differences and you just mention the differences. So just take note about that when it comes to the interpretation. All right, let me just move on, okay, because of time. So those are the, but here's the next point. It doesn't mean that all section of the frontier is better or has improved. For example, some of them portion, and I'll show you a couple of examples. Some of them, you see that the frontier is closer to each other. You know, some of them, the gap between this frontier and this frontier, the gap is wide. So on average, the score that you are getting, the 21% movement, is an average movement. When you go and check carefully, you see that between this A group, A and year 1 and year 2, it was even constant. And between the others, it was moving. Okay, but the average value is what has been given. So individually observed shift will be different since the frontier wants to be parallel. Okay, if they are parallel, then there is, you know, there is no even, you know, the shift is constant. Okay? So the movement is the same throughout for everybody. But overall improvement doesn't improve all parts of the frontier. So just take a typical example. I'm giving you 2 examples. One is with time, one is with group. Now, the one that we calculated, that had 21%. That is the one on the right here. Okay. So this one on the right here, that is the one that we just did. Okay, and it was showing 21% improvement. And you can see that this is frontier 1 and this is frontier 2. And you can see that the frontier 1 have moved closer to towards the origin. And so that is why we say it's 21% improvement. Why is it not 50% improvement? Why is it not 100% improvement? And the reason is because even though there is 21% improvement, it's not all sections of the frontier that have improved. It's not all sections. Can you tell me which section of the frontier has not improved? Which section of this frontier here has not improved?
Dog, the A section.
The A section. Exactly. The A section had no change at all, no improvement at all. the C section here, the improvement was very little. Majority of the improvement was with the B section. Okay, that is where majority of the, so it is B in particular that is causing much of this frontier, movement, average global frontier movement. And so you have one single score, and that single score is made up of multiple examples. And when I show you those multiple examples, you come to realize that, oh, I see. No wonder that is the case. For some of them, when you calculate the, in fact, it was this that led to the geomean of 0.95 and the geomean of 1.15. All right. Now, when you look at this second one on the left here, you will see that there are three groups: red squares, blue stars, and then green dots. And you can see that the frontier is intersecting. And even at the point of intersection, you can see that there has been no improvement. Now, of course, that is not about time, it's about groups. Okay, you are talking about domestic against international banks. So you can see that there is no difference at all at that section here. But there are wide differences, in this other place. And we are talking about between the green dots and then the blue stars. So on the basis of this, you can use this to check whether there is a significant difference. So in this case, it's not about improvement or decline, it's about difference. And that difference, even though it's about difference, it will still have to know whether the difference is a good difference, a good one or a bad one, a better one or a worsening one. And again, the green ones, because the green ones, the way the green frontier looks like it's more towards the origin in this input orientation. Because the green one is more towards the origin, you will notice that if we are to calculate these scores, the frontier for the green one is going to be better than the frontier for the blue one in terms of groups, because these are for groups. I hope that is clear. All right. And please note, this is so powerful that this is a representation of productivity. That's what I want you to note. This is, we speak of this as a measure of productivity because the measurement is global. Okay, so I have some questions for you. The first question I have for you, and I need all of you to come with your answers or your understanding. What is the difference between the global frontier shift that we are looking at and then the classical frontier shift, the normal classical Malmquist? There is a technological change version of that. Okay, and then there's an efficiency change of that. That technological change version is called frontier shift, the classical frontier shift. And what we are just looking at here is the global frontier shift. What's the difference? Based on all that you are listening, what is the difference? Who can tell us? What is the difference between the two? Because one is a classical frontier shift, the other is global frontier shift. What's the difference between the two? What's his name? Prince, are you here?
Yes, Doc, I'm here.
So what is the difference?
So the global frontier shifts looks at the shifts of the industry. For all the DMUs, Malmquist frontier shift takes into consideration the individual DMUs.
Okay, Christopher, what do you understand by the two? This global frontier shift and the classical one?
Doc, I think with the global frontier shifts, it can compute both the shifts across time and then across groups. unlike the classical.
Okay. Yeah, that's not bad. That's not bad. That's okay. But we wouldn't have called it global frontier shift if it was about groups. We would have called it global frontier difference.
Yeah.
Still on the shift. What is the difference between the two? The global frontier shift and then the global frontier difference. Francis.
Yes, Doc, the global frontier shift take into account the geometric mean.
The classical
whereas
one also takes into account the geometric mean. If you remember classical one, the technological index, it also takes the geo mean. You remember we raise it to the power 1/2.
Okay.
But still, there's a difference there, even in that one. Miriam, what is the difference?
Doug, the global frontier shift looks at the all-time period, but the classical consider 2 time periods.
Yeah, that's the main difference. So they both take geomean, but the classical is taking geomean for 2 time periods, whereas the global is taking geomean for all time periods. That's it. Even if, and this is important, the classical does for 2 time periods, 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 for 2 time periods. And then what will it do? It will now calculate, it will now take the average. Sometimes it talks about the average for the industry as if it is a global, but it didn't do the calculation on global terms. So please note that the global is taking the geomean for all time periods. The classical is taking the geomean for 2 time periods. The main difference is that global is dealing with all time periods and all firms. Classical is dealing with firms within just 2 time periods. Okay, next one. Why can we say that the global frontier shift provides a better estimate of the true overall frontier shift than the classical one? Why can we say that the global frontier shift gives a better estimate? It comes from the principle of the same thing that we just mentioned. Why can we say that it gives a better estimate than the classical? Kizito, are you here?
Yes, Doc.
Tell me.
I'm here. So I can say that the GFS provides a better estimate of the true value because the GFS look at the efficiency globally than the frontier shift. More globally than the
What do you mean by
frontier
more
shift.
globally?
Because for the GFS, we compute the global estimation by not doing the estimation between 2 time period and doing the average. We compute it by doing the geometric means globally.
Okay. Who can add something before I come in? Who can add something to the difference? And please, I will encourage you to bring yourself into this discussion because you'll be surprised that probably all of you will do this to bring out the differences. Okay, so yes, the global frontier shift is taking every time into account. It is taking everything from the perspective of everyone in the industry. Okay, that's all. If you are going to compare, even if you are going to compare two players, you're in the same club, okay, in the same club. Let's say in Man United, you are comparing Rashford against Fernandes, the same team. And then you decide to ask only Man United team members. Or you decide to ask, you decide to ask, maybe not only Man United, maybe a few players within the team, 5 of the players. So 5 of the players, their opinion or perspective is going to be narrow than if you have asked all of the players. If you ask all of the players, it's better. That's the word I mean by better estimate. It's better than if you ask just a few. Suppose you are comparing Ghana and Nigeria, and you are asking Ghanaians, and you're asking Nigerians. So you ask Nigerians, Ghana and Nigeria, which is better? That Nigerian will say, most Nigerians will say Nigerian. You ask Ghanaians, Ghana and Nigeria, which is better? Most Ghanaians, most, not all, will say it's Ghana. And a few will be the cross periods. They will say that. Okay. And there are few. So it doesn't make the estimate better. But what if you want to know Ghana and Nigeria, which is better? After you've asked Ghanaians and Nigerians, you now ask Togolese, South Africans, Egyptians, Malawians, Zimbabweans. Okay? Now you are going to get a better estimate of the real difference between Ghana and Nigeria. And so the global frontier shift provides a better estimate. The estimate is more reliable of the overall than the classical. Finally, what is the difference between the global frontier shift and the global frontier difference? The global frontier shift and the global frontier difference. Michael.
Okay, so I think the global frontier shift is the shift in technology of by considering all DMUs over all time periods, or all groups over all time periods. And then the global frontier difference is the relative change in, I don't want to use difference again, but then if we are comparing a technology at a particular time with the global global technology, if we want to compare a technology at a particular time with a global technology, we then get the global frontier difference.
You've tried, but you've succeeded in confusing me. So let me go to Francis. Francis, what is the difference?
Yeah, Doc, like Mike said, the difference is the shift has to do with time and the difference has to do with groups.
But what he said didn't look like that's what he was saying. You see how short yours has been. So watch. Let me ask you guys, does the global, and still on you, Francis, does the global frontier shift consider groups?
No, Doc, it doesn't consider groups.
Does the global frontier shift ignore groups?
Yes, Doc, it ignores group.
Does the global frontier difference ignore time?
Yes, Doc, it ignores time.
That's a point. So if you have a data set of 2,000 firms between the year 1998 up to 2022, and you look at that data, what the first thing the global frontier difference is going to do is it's going to scrap off those years and then consider each of these observations, even if it is banks, it's going to consider each bank as separate. So if you have a bank like APSA in 2008, 2009, 2010, it's going to consider banks in 2008 as a different bank from 2009. Different observation. But when you go to the other one, the global frontier shift, once he sees, all he sees is that he sees the years. It doesn't even see whether there are different groups of banks like foreign, domestic. No, it doesn't see those differences. It only sees time. All right, so that's it. Okay, so take note of the difference there. Okay. Now, let me go to this. If you look at this graph I'm showing you here, how many data sets do you think are here? How many observations are here? Miriam, how many observations?
Dog, 2.
2 observations.
Yes.
No, that's not correct. Michael.
Dog, there are 12.
Yes, there are 12 observations. Explain them, Michael.
The observations are the stars, the circles, and then
How
the
many are the
triangles.
stars? Tell us the numbers. That's a...
Okay, the stars are 4, and then we have my hand that's covered. Okay, we have 4 circles too, and then we have 4 triangles.
That's the point. Christabel, how many groups are here?
Doc, 3.
Okay. Now watch it carefully, those 3 groups. Which group or groups form the global frontier? Friends, which group or groups form the global frontier or can form the global frontier? Friends, are you there? Okay, Mimi.
Hello, Doc.
Yes, Mimi.
Hello.
Yeah, dog, the circle and the stars.
Why? I was a lottery.
No, dog.
So
Because
I'm
they
asking you
are,
why.
What's up?
You don't know why you said them.
dog, it's because the frontiers connecting the global frontier will be connecting the circle and then that's of the circle frontier and that's of the star frontier.
Yeah, but why were you struggling to tell me the why?
I didn't know that I muted myself again.
All right, so the global frontier will be picked from somewhere here. If I were to draw the global frontier, I'll move this section to this, then move from here to that, and then move from here to that, okay, before I continue throughout the rest of this. Okay, so that is where the global frontier will be passing. And therefore, the 2 frontiers will be those stars, the extreme stars, and then the extreme orange. They would have formed that there. Which frontier or which group is totally enveloped? Which group is totally enveloped? Christabel, which group is totally enveloped?
Doc.
Completely enveloped. Which group?
The triangle.
Yeah, the triangle group. You see, the essence of me telling you these things is because of everything that we are discussing. Okay, now let's move on.
Doc,
Yes.
please, can we go back to the diagram? I have a question.
Yeah.
Okay, so, although we have 3 groups and then only 2 frontiers are identified or can be traced from the diagram, is it possible that there is a way you can leave the blue frontier out and then draw another frontier with the triangles?
Yes. I was only looking. Oh, yeah. I was just comparing the circles and then the stars. That's why I drew those.
Okay.
I could compare the circles and the triangle, and that means I can draw it.
Okay. Thank you.
So even though there will be several ones, and you're going to see that in the practical session, even though there will be several ones, you are dealing with 2 at a time, 2 at a time, 2 at a time.
Yeah.
Okay. Now, that is the global frontier shift. To be able to get a global Malmquist, you will need the global efficiency change, add that to the global frontier shift, and then you can now have the global Malmquist. And the global efficiency change, when you calculate it all, you just have to take the geometric mean, and then that's it. It gives you a single score. The way that one is the same as the standard one. When you have calculated the classical one, and then for individual ones, and then after that, you take the geo mean of that. So there's no big deal. Okay. So on average, the ability of the firms to raise, decrease, or stabilize the efficiency between the 2 time periods, given the technology, that is the efficiency change. The reason why we call it global is that you take the geo mean of the score, and then you get one single figure, and that is the global. If you get a score greater than 1, it shows an improvement. If you get a score less than 1, it shows a decline in efficiency, on average, global efficiency. So now we can combine the 2 and have our global Malmquist. What is a global Malmquist? The global Malmquist here, under the, of course, constant retention scale. This global Malmquist is the efficiency change, the global, and watch the efficiency change global. Okay. Efficiency change global, you can see that this one here is for just 2 time periods you are dealing with. Okay. 2 time periods, that's what you are dealing with. And that is why we say it's just like the other one. And then you take the geo mean, okay, and the geo mean is just for the firms and not for the time. But when you look at the global frontier shift, this one here, you will notice that the terms here are for all the firms relative to what 2 groups. Okay, so relative to group T and relative to group T plus I, over all time periods, over all firms, and over all time periods. And that is a difference. I've decided to split the 2 so that you see clearly the difference between the 2. So the global frontier shift is telling you the overall relative distance between any 2 frontiers. And then the Malmquist, the global Malmquist, is a product of the 2, the JEC and the GFS. Now, for your further research, you can think about 3 or 4 factor decomposition. This is just a 2-factor decomposition. Okay. You can think about a 3 or 4 factor decomposition. Okay. That's what we are working on for this global estimation. It requires that you think deep. In fact, I've been able to do the 3-factor decomposition on the line of this guy. That is taking the global efficiency changes, splitting that into 2, you can do that. But this part here is something interesting. All right. So now that we've been able to get the theoretical underpinnings of all of this, we should be able to go to a real-life example. So guys, are you ready for the real-life example, or we give ourselves some break? Which one? So we are going to take a 5-minute break. When we come, we are going to take this data set. We're going to use R software, estimate the whole thing that we have done so far. So just take it. We'll return very soon.